Okay, they love these kind of questions. This is a bit more complicated than normal years, but they love this idea of these sort of I plus j and I minus j for the elements. So let's look at a 3 by 3 matrix. This is first row, first column, so it's 1, 1. Then you got first row, second column, first row, third column. So remember, it's Roman Catholics. That's how I remember it. Remote control cars, other people say. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. So if you look at this element here, that's 1, 1. So for A, that's going to be 2 times the 1. Let's just remind ourselves it's x and then y, or another way to look at it is I and j. So we know it's 2 times the 1 plus 1. So we know that first one for A, that's going to give us 3. And B is the I minus the j, so it's the 1 minus the 1, so it's 0. So if we add those two together, we get 3. So not A, not B. See how quickly we can get rid of some of these points. Now, all we need to do now is a couple more elements. All right, well, okay. Let's have a look at another element. Let's try this one. So 2 times the 1, plus, which is 2, plus the 2, that gives the A is going to be 4. And then the B is I minus j, so it's 1 minus 2 is minus 1. Add them up, you get 3 again. So that element is 3. That only leaves, all right, we've already quickly got it. So can't be this one, can't be this one, must be this one. You can keep going for more and more elements, but do get the practice of these kind of problems, because again, that's a guaranteed going to be on the test. So let's just do one more element to see how we're going. Let's do this element, and let's look at a writing here. So remember, it's 2i plus j, and then you got 2 times the 3 is 6, plus the 2 is 8, and then for the b it's I minus j, which is 3 minus 2, which is 1. Sum them up, you get 9. You can do another way of just going, all right, 2i plus j is for the A, and then I minus j is the B, and we're just adding those. You can actually simplify that to being, okay, it's 3i is actually what the answer is. That's another way to simplify it. So it's just triple whatever the A is. And if you think about, if you're just tripling whatever the X value is, if we look at the highlighter, that's the X value, 1, 2, 3. So it's going to be 369. That one's 369. It's the only one. That's another way of solving the same problem, but it doesn't take long either way you do it. All right, this is it's a tricky problem, but we can actually, the key to it is to look at this remains constant point here. And what are the consequences of that? It's saying that the F1, so the next month, will be the same as F0. So we know F1 equals F0, which means it all equals this thing, right? And this formula down here, which is kind of a recurrence relationship, if we say that's F1, then that must be F0, but we already know that F1 is the same as F0. So F0 has got to equal this. So we know 50,000, 10,000, 7,000, 0 has got to equal 0.65, 0, 0, 0, 0.25, 0.75, 0, 0, 0, 0.20, 0.95, 0, and 0.10, 0.05, 0.05, 1 times 50, 1, 2, 3 again, over 10, 1, 2, 3, 7, 1, 2, 3, 0, plus whatever B is. This is B. It's going to be a 4 by 1 again. Has got to equal the same over here. So just take this and put it into your calculator, and you will find. So if we look at this, we can solve all that. Let's just make it a bit neater down here. We know 50,000, 10,000, 7,000, and 0 equals 32,500, 20,000, 8,650, 5,850, plus whatever B is. Well, remembering to label our things, keep running out of room here, the red pen here. So remember, this is Y, A, D. So if we've got 50,000 here, and we need to make 32,000, then we need to add, well, do the maths. We need quite a few young fish, but the young fish, that looks like we need to buy 1,000. So the problem with C is that would actually, we need to buy them to add, we've got to add to make 50,000. So that can't work out. Buy 50,000, no, that's not going to work either. So that rules out the young fish. Let's look at the juvenile fish. So we've got 20,000 plus 10,000. Well, that would make us 30,000, not 10,000. We've got to actually 10,000. Cool, so we can rule that out. And so now we're going to look at adult fish. So you don't have to look at the dead fish because, you know, you don't need to buy or sell dead fish. So 7,000 is the same as 8,650 minus 1,650. Minus would be sell. And that's why you can tell the answer for question 7 is A. And very few people got this right. A lot of people got confused. Maybe someone did the right maths and they saw this and thought it was good, but they got the idea. Sell would be subtract, okay? Buy would be plus. It's because you're adding more fish to your stocks. Quite a tricky question. So the first part was to realize like F1 equals F0. And so that's why eventually we just knew that F0, which was all this, which we then had to come down to here, is the same as taking that whole matrix, timesing it by F0, because that was our F0 there, which simplified to this, and that was plus a B matrix. So the two numbers on the right must add up to the number on the left. All right. That was a good question to get lots of marks on and boost you up your ATAR. Okay, this was done very, very badly, but we can see that on a transition matrix, the columns have got to add up to 1. So this has got to add up to 1. 0.3 plus 0.2 plus x equals 1. You can see that we need x equals 0.5. So x equals 0.5. 0.2 plus 0.2 plus y equals 1. So therefore y has got to equal 0.6. And we know that v plus w plus z must also equal 1. Hey, wait, that's already d. D is true. We can eliminate d. We can also see that y is actually bigger than x. So that is true. 0.6 is bigger than 0.5. We can also say x plus y, that's 0.5 plus 0.6, that's 1.1. That's already bigger than 1. So E is already true. So we're already down to A versus C. I'm going to figure out what the values then are of V, W, and Z. It's some algebra here. So we got to take this and this and this and put that together. So we know we should be saying that S1 equals TS0. So S1 we've got is 29, 13, 33. T is 0.3, 0.2 V, 0.2, 0.2 W, and 0.5, because we know that now, and 0.6 for Y, Z, times 40, 15, 20. That means we've got this times this gives me this. And we can do that for each row and get 3 equations, which should probably help us out, because we've got to have work out V, W, and Z, I think, by the looks of it. So let's have a look at what we need to be doing. So that first row is 0.3 times 40 plus 0.2 times 15 plus V times 20 has got to equal 29. So that's 12 plus 3 plus 20V equals 29. So 20V equals, just get rid of the 15 from this side, get rid of that and that. That becomes 14. Divide both sides by 20, we get V equals 0.7. So we can actually write that in there. There we can go, that is 0.7. All right, we're going to have to get some more things, values in here. But we can already see V is greater than Y. So we can actually already say V is greater than Y, so we can eliminate that. But let's check some more equations. Okay, we can also look at the next equation, which is again those same numbers. So we can say 0.2 times 40 plus 0.2 times 15 plus 20W equals 13. So that's 8 plus 3 plus 20W equals 13. 20W equals, well, that's 11. And take away that, you get 2. So W equals, divide size by 20, 0.1. And then if we were to try the next one, we get 0.5 times 40 plus 0.6 times 15 plus 20Z equals 33. That's half of 40, which is 20. That's 3/5 of 15, so that's 6. If I'm correct, I'll just double check that. Or even 9. Plus 20Z equals 33, so that's 20Z equals, make sure it looks like a Z, not another 2. We take away the 29 equals 4, so divide that through, we get 0.2, and that makes sense because that was 0.7, that is 0.1, that is 0.2, they all have to 1. And the last thing, I mean, we're just really being pedantic here and thoroughly checking everything. W is greater than Z. W is 0.1. Z is 0.2. So that one is wrong. Therefore, it's right. The answer was A. A lot of double checking there, but again, elimination would have got you there fairly quick.